Okay, so we have a question here. Find the values of x given that log base 5, open brackets, x squared minus x plus 2, close the brackets, equals 2 plus log base 5, x minus 1. All right. So for part A here, what we must do is we must put every term in log base 5. Once we do that, then we can get logarithms so that we remain with the equations so that we can solve. Okay, so we write it down like this. So basically, this 2 in this equation, we have to put it in log base 5. All right, because as you can see, every term on the left hand side and as you can see on the right hand side, we've got log base 5. So these 2, we need to convert it into log base 5. So in order to convert numbers into a logarithmic form, you just use this simple formula here. X equals log a to the power x. Okay. So x basically in this case is 2. All right. Log a is log base 5. All right. So we put it as this a again. Where there's a, replace it with 5. Where there's x, replace it with 2. So we get log 5, 25. All right. So 2, if we have to write it in logarithmic form, it is log 5, 25. Any questions on that? So you use this formula here. Okay. X, which is the number you have in the equation. So in our case here, x was 2, equals log a. A is 5, log, because we're putting it in base 5. All right. So 2 equals log 5, 5 to the power 2. And then this is what you get. Okay. So on your calculators, you can verify this, okay, even on Google. Okay, just type in log base 5, 25. What does it equal? You will see that it will give you 2. Okay. Yes. Any questions before I move further? Okay, so we rewrite our equation here. Log 5 x squared log base 5. It has to be in base 5 because if you just put log, that would be in base 10. Okay, it would be in base 10. So if you do log base 5, 25, then just write equals. Just go on Google, just type it in Google, just type in log 5 25 equals, then Google will give you the answer. No, I just wanted you to verify, colleagues. No, I just wanted you to verify that log base 5 25 equals 2. I just want you to verify so that you don't think, Mr. Muava is using magic and he's using tricks. Okay. So this 2 becomes log 5 25 plus log 5 x minus 1. Okay, because as I said, with this equation here, what you want to do is you put everything in log base 5 so that you get rid of the logarithms, so that you just remain with the algebraic expressions. Okay, that's with question A and B. Okay, that's what's happened. That's the format you use. Put every term in the base, in the logarithm that's given to you. Then you get rid of the logarithms. That's when now you can solve. Okay. So now here on the right hand side, okay, remember whenever this, if we remember the power rule, okay, let me just show you the power rule so that we apply the power rule. Oh, actually, I think we have it here in the other boards. Where was that? Where we put the power rule? Yes, this power rule. Okay. So we're going to rewrite this one like this. I'll bring the power row onto the board. Let me just do what I'm trying to do with the power row. Then I'll show you on the board how we did it. Yes, this log 5 25 plus log 5x minus 1. If we apply the power rule, it can be written as this: log 5 open brackets 25 multiplied by x minus 1. Okay. If we apply the power rule, we can rewrite this: log 5 25x minus 1. Okay. Are we okay with this, colleagues? We've moved, where is this? We've moved from here. Our equation was in this format. Where's the draw to? Yes. Our equation was in this format. So we have rewritten it like this. That's what has happened here. Okay. You had log 5, 25 plus log 5 x minus 1. So we've rewritten it like this. Okay, that's what has happened here. Okay. So as I said earlier, once you've got the logarithms on both sides of the equations, you get rid of them so that you remain with normal algebraic expressions so that you can solve for the value of x. So once we get rid of these logs, what will remain with is now x squared minus 3x plus 2 equals 25 open brackets x minus 1. Okay. As I said, you want to get rid of the logarithm so that you remain with the pure algebraic expression so that you can solve for x. Any questions before we start to solve for x? Mm-hmm. Two changes to log 5 district. I said whenever you want to convert, okay, whenever you want to convert a number, okay, into logarithmic form, you use this equation here. Okay, x equals log a to the power x. Okay, you use this equation here, right? A number into logarithmic form. That's the equation you use. A number by itself. mm, It can be any number, but always take note of the base that is there. Okay. For example, okay, let's say 3. You want to put it in log 5, right? Let's just use, yeah, 3. You want to put it in log 5. Okay. So we use this equation here. We say x equals 3, since x is the number. A equals the base of the log, which is 5. Okay. So we're going to do x equals log a to the power x. So in this case, our x is 3, our a is 5, so 3 equals log 5, 5, then a here again, where there's a, replace it with 5, then where there's x, replace it with 3, 5 to the power 3. We're trying to convert 3 into log 5. Okay. As I said, if you want to convert a number into logarithmic form, maths, yeah. Okay. If you want to convert a number into logarithmic form, all right. You say so. In this example here, I said want to convert 3 into log 5. Okay, that's where the 5 is coming from, madam. Okay, that's where the 5 is coming from. I want to convert 3 into log 5. Mhm. Yes, sir. No, I was here. I'm just illustrating. I'm just illustrating. Okay. It's just an illustration. Okay, madam. This is just an illustration. Here, we want to convert 3 into log 5. Okay. This is just an illustration. That's where that 5 has come from. Okay. So that's why. So, what was where were we on? So 5 to the power 3 is 125, right? So 3 in log 5 is log 5, 125 here. Okay, if you want to write 3 in logarithmic form. Let's try another example, okay? Because remember the purpose is everyone must understand, okay? The way I measure my effectiveness, okay, because effectiveness is when the students understand, okay? So here, I have to make sure everyone has understood, okay? So before we go back to this question here, let's say, for example, you want to convert 6. No, listen to this example before you copy, because copying without understanding, there will be, you won't gain anything. Have you seen? So just listen to this last example before you copy. Okay. 6, want to put it in log 2, log base 2, basic. In log 2. I want to put it in this format here. So you bring the equation x equals log a to the power x. So in this case, x equals 6. A will equal 2. Okay, because that's the base we're trying to put it in. Base 2. Okay. So you're going to put here 6 equals log 2. Sure. How many people can see? Some mathematics. Okay. Uh-huh. Yes, is that a question? Okay, okay, okay. Okay. So 2 to the power 6. Mm-hmm. 36. Sure. Let me check on it. 2 to the power 6. 2 to the power 6. Hey, sir. Remember, when you say something parallel to cause confusion in the class, 64? Yes. 64, yes. So 6 can be written like this in log 2. Any questions? Mr. Twambo, Mr. Vince? Okay. Mr. Vincent. Are you sure, sir? Madam Betha, Madam Caroline. That's Mr. Foster. Yes, Mr. Foster. Yes, you joined in late. You joined in late. Just hold on, Sam. But yes, okay, I'm coming to you. Just hold on. Yes, Madam Sylvia, are we okay with that? Madam Yvonne. Okay, just to make sure we're all okay with that, as I'm explaining to Mr. Okay, as I'm explaining to Mr. Foster, convert 4 into log base 5. Okay, 4 into log base 5. Okay, a shortcut, just remember 5 to the power 4. Just get 5 to the power 4 and put a logarithm there, and then you get your answer. Okay, the more you do this, the shortcut is just put 5 to the power 4 and you get your answer. Even here, you just saw you put 2 to the power 6, we got our answer. Okay, yes. As you are solving there, Mr. Foster, we are doing this question here. We are trying to solve for x. Yes, we're trying to solve for x. So when you see an equation like this in mathematics, okay, you first thing you want to do is you want to get rid of the logarithms so that you remain with this. Have you seen this equation in black here? You want to remain. You want to simplify the equation like this. Okay. From this form, you want to simplify it like this. Yes. You found 5. Mm, uh-huh. Make you have to make them balance. One on the left hand side, one on the right hand side. Then you cancel. That's why we applied the power rule. That's why we applied the power rule so that there is one. Yes. So, Mr. Foster, these two here is what we are explaining here. How to convert a number into a logarithmic form. You use this formula. Okay, colleagues, has anyone found this one? So you explain so that what have you found for this one? Have you found log 5, 625? Has anyone found the answer for this one here? Mr. Twambo, since you said yes, I've understood. Have you found the answer for that one? We're into log base 5. Mm. 5 to the power 4. Yes, 625. So colleagues, pay attention finally so that we go back to the question there, okay? So when you're converting a number into log form, remember this equation. If you can't remember this equation, remember this. Just make the number as the power of the base. If you can't remember this equation, just remember, make the number as the power of the base. But if you can remember this equation, x equals 4, a equals 5. So it's going to be 4 equals log 5, 5 to the power 4. And 5 to the power 4 is 625. Okay, colleagues, that's how you convert a number into log form. Okay, and that is how we have done with this 2 here. Okay, to make it into log 525. That's what we did. Then after we did that, if you see logarithms being added, apply the product rule, okay? If you see logarithms being added, same base, log 5 here, log 5. You see logarithms being added, apply the product rule, this one here, okay? Here, this is log 5, 25 plus log 5 x minus 1. Okay, so m is 25, n is x minus 1. So you can rewrite it as log 5, 25 times x minus 1. Okay, colleagues, if you see logarithms being added, apply the product rule. What if you see logarithms being subtracted? What rule are you going to apply? The product. No. Quotient rule, yes, rule 2 here. Okay. I said subtracted. Okay. Sometimes the equation, they might bring it like this format here. You have to take it back into this. But usually it's addition and subtraction. So for now, just remember, if you see logarithms being added, apply the product rule. You see they're being subtracted, apply the quotient rule. And that was done here. These logarithms are being added. We apply the product rule. Okay, so it becomes log 5, 25 multiplied by x minus 1. Okay, then after that, since we have one log 5 on the left hand side, one log 5 on the right hand side, you can cancel them out. Okay, you cancel them out, colleagues. Okay, so that you remain now with this simplified expression. So here, colleagues, let's see who remembers mathematics. What do we do next here? Yeah, huh? Yes. Wonderful. Mm-hmm. Then what next? Mm. Okay, yes, you can do that, but yes, it's a quadratic. It's a quadratic, yes. So let me just say something, sir. Just hold on, okay. So, sir, what I've said for matching like terms, oh, you can do that, but eventually you see that you end up with a semi-quadratic equation, and you have to bring the number back to the left-hand side, so you make a full quadratic equation, okay. So, what you can do, sir, okay, instead of doing that, doing the long cut, anytime you see a quadratic equation on one side, just take all the other terms on the other side too. So here is we just take all these terms here to the left hand side so that we complete this quadratic equation, and then we solve it because we've got a quadratic equation here. Okay, that way you make life easy. All right. So here we're going to have x squared minus 3x. Now this is where you put like terms together. Okay, this 25x comes this side, becomes negative 25x. Mhm. Then this negative 25, when it comes over this side, it becomes positive, right? Equals 0. Okay, because remember with quadratic equations, on the right hand side, you always have to have a 0. Okay. So let's simplify this equation, colleagues. What do we get? What does it simplify to? Mhm. 23. How? Mhm. Yes. Mm-hmm. 27. Yes. Colleagues, are we all okay with this? Any questions, queries? All right. How do we solve quadratic equations? Who remembers how to solve a quadratic equation? Before I take if- yes, quadratic formula. If you've mastered it in your heart, always use it because it always works. Factorization doesn't always work. Sometimes factorization can fail. So those who remember the quadratic formula, yeah, okay. Okay. But let's use factorization. Mm-hmm. So let's solve it. I'll teach you from the basics. Those who remember how to solve, tell me what answers you get. But those who have forgotten how to solve, um, this is how you use the factorization method. Okay. A represents, and it's very important to remember what these letters represent because in the assignment we're going to see more quadratic equations. Okay. A represents the coefficient of x squared, basically the number in front of x squared. In this case, the number in front of x squared is 1. B represents the coefficient of x, the number in front of x. The number in front of x, negative 28. C represents the constant, the number without a letter. So in this case, our constant is 27. Any questions? Please remember what these A, B, and C mean, because they are coming back. They're coming back with a vengeance in the incoming questions, okay? Yes. So once you found your A, B, and C, you say, what? Okay, what is A times C? 1 times 27. All right, that gives you 27. So you have to find two factors of 27. Okay, two factors of 27 that when you add them, they should give you negative 28. And when you multiply them, they should give you 27. Okay. So you have to find when you add them, they should give you B. When you multiply them, they should give you the product of A times C. Okay? Those two factors. When you add them, they should give you B. In this case, they have to give you negative 28. When you multiply those two factors, they should give you 27. Okay? So, thank you, sir. Negative 1 and negative 27. When you multiply um, negative 1 times negative 27, you get positive 27, right? When you add negative 1 plus negative 27, remember positive and negative make negative. Negative 1 minus, minus 27, you get negative 28. And you just write it like this. You always have to do that. Multiply A times C. After you found out what your A, B, and C is, multiply A and C. Once you've multiplied A and C, the number that you get, you have to find factors of that number. Now, when you multiply those factors, they give you the same product of A times C. And when you add those numbers, they have to give you what B is basically. Is that okay, madam? No, this is just because I'm explaining here. That's why it's looking wrong. Okay, because of the explanation. That's why it looks long. But once you've grasped it, let's see. One, two, three, four, five, six, seven, maybe like 8 lines. Pretty, not really that long though. Yes, Madam who was asking on the who was the Madam asking on the 8 times? Okay. Do not worry, I've got practice questions, okay? So that you fully grasp this. Okay, if you've got children in grade 12 or 11, don't feel shy. Just say, okay, just walk me through quadratic equations. And those are late G11, G12. So that you practice with them. You practice with them and then even tell them that, Sonny or daughter, this is coming in university. So do not forget this stuff. It's very vital, colleagues. It's true. Especially if they'll be doing full time. At least you're doing distance. So distance, it's this is watered down, okay? If you're doing full time, you cry. Okay, so we just solve because remember with a quadratic equation, you're always going to get two values, okay? Since there's to the power 2 here, so you get two values. If it's to the power 3, you get three values. If it's to the power 4, you get four values. So x minus 1 equals 0. So you're going to say x, you take the 1 over the side, x equals positive 1, or x equals 27. So those are your values of x. And the, that's where the question ends.